Hi folks, Antonio here again. Very nice to be here with you all. In this video, in the second video, I am going to continue discussing with you guys a little bit again about the text-based strategy video game that I'm writing. Today we're going to be talking about the battle function, okay? At this point, we're still not going to integrate the create a player army function. That is the function that creates the player's army, obviously, and the battle function. Okay, there's some tweaks that I gotta do. As you guys can see, I've got Visual Studio Code here in the background. So yeah, let's get right onto it. And today, I'm going to do it a little differently. Last video, I showed you guys how the program ran before actually showing you the code. Today, I'm gonna flip it over. I'm gonna show you the code before, and then we're gonna see how the program runs. Okay, so that's it. Hope you guys enjoy it. Okay, so let's talk about this. Before talking about the battle function, we have here another function which I named resulting damage. Okay, it returns an int, okay, an integer, and it takes two arguments, an attack and a defense. Okay, both are ints as well. Um, so for example, if you're attacking your enemy, right, or if your enemy is attacking you, okay, so the difference, okay, if attack minus defense is greater than 0, then you're going to return the difference. Okay, so attack minus defense. So if you have an attack of, say, you attacked with a value of 10 and the defense is 5, okay, so then the resulting damage will be 5, right? However, you can attack at, say, that you have a value of, you get an attack of 15, right? But your enemy's defense is 20. So 15 minus 20 minus 5, right? The result. So, in other words, we cannot have a negative resulting damage. So return 0. Okay? Um, and we have another function here, which is check battle over, okay, which is going to check if the battle is over, okay, as the name implies. It takes several parameters here, okay. You guys can take a look at the code afterward. It's going to be on GitHub, and link down below in the description. And it's going to return struct, which I called a battle over struct, which you guys can take a look at here. Okay? Okay, so basically, what's gonna make a battle end, okay, is if either the player or the enemy reaches this value here, okay, which I called minimum battle strength, okay, this variable, this integer variable, okay. Um, okay, so if the initial player's strength, because as you're gonna see, in every turn, the strength of both the enemy and the player, assuming that they got damage, suffers. Okay, you guys are gonna see that. So, if the initial player's strength is less than or equal to the initial enemy strength, okay, so the minimum battle strength is going to be equal to the initial player's strength divided by 2. So if you start your battle with a strength of 3,000, okay, if you reach 1,500, 1,500, you know, the value of 1,500, then the battle is over and you lose, okay? Same for the enemy. Okay, so at every turn, we're going to check if either the enemy or the player reached this minimum battle strength value. Okay, so if the numbers of the current player are less than or equal to 0, so the or if the current player's strength, because as I said, at every turn you're going to be losing strength if you take damage, is less than or equal to the minimum battle strength, then the battle is over for the player. Okay? And we're going to make another check here, right? So if the current player's numbers is less than or equal to 0, actually, if it is equal to 0, okay? Because when we're coding, this value could actually get negative, so it doesn't make sense to have negative soldiers now, does it? So I set it to 0. Okay, the current player's number is set it to 0. So, however, our soldiers have bravely fought to the last man. Okay, else you have been beaten and blah blah blah. So battle. So the battle over struct variable that I created here. Okay, battle over is going to be equal to 1. So true, the battle is over. But did you win the battle? No, that's false. So 0. So you're going to return is battle over, which is this struct here. Okay. And this is the contrary, right? So this is the condition for you to win, right? So the numbers of the enemy had to be less than or equal to 0, or the current enemy strength has to be less than or equal to the minimum battle strength. Okay, nice. That's pretty neat. And basically, this here is the same as this, but we've flipped it over. Okay, so the enemy. Okay. All right. So this is the same as this. Okay. Or let's assume that the battle isn't over, right? So the battle isn't over, and of course no one won because the battle isn't over. Okay. So battle isn't over 0, and the battle won also 0. Okay. So basically we're going to continue the battle until this condition here becomes true. Okay. And of course, if you beat the enemy, battle 1, battle over 1, and this else if part of the code here. Okay, so let's go to the battle. Okay, so here's how the battle works. Okay, it is gonna return a battle over struct. Okay, it's gonna return a battle over struct, same as the check battle over function. Okay, and it takes 2 arguments, which are 2 pointers, by the way. A pointer to a struct of type army for the player, and another pointer of struct army, okay, which is for the enemy. Okay, so 2 pointers here as arguments. And we need pointers in this case. Actually, in my opinion, it's better to use pointers in this case, because if we don't use pointers, okay, our code is going to basically make a copy of struct army and a copy of struct army, player's army, which we've created in this main function here. And it's going to make a copy of the P enemy army, right? So it's going to be make a copy of all of those values, of all of those variables that they're going to be stored here. So in other words, it's more memory that it's going to be occupied now, right? And yeah, so and plus, if we use a pointer, it's going to be acting directly in memory. So if you lose soldiers, I don't need to return anything here, because I've acted directly in memory, and those values, the numbers of soldiers you have, the commander's points that you have, they're gonna be changed, basically, because you're acting directly in memory. So yeah, I very much enjoy using pointers. Okay, so let's drink some water right before we continue. Okay, where was we? Okay, so we've got some variables here. Okay. Continue number, it's just press a button, to continue, to the next turn. Okay. Int, start battle. Okay, so right here, just so we can click it and start the battle. And the initial player's numbers. Okay, so we're gonna dereference the pointer to the player's army here. Okay, and we're gonna get the initial numbers. Okay, the numbers which you started the battle. And we're gonna store it in this variable here. And this is gonna be important, for our check battle over function, which we're gonna call in a moment. And same for the initial enemies numbers here. And same for the initial player strength, because we need to check not only the numbers, but also the strength. Those are the two conditions, for our battle to be over. Okay? And yeah, a variable here of type struct battle over struct. Okay, so that's it. So your battle is about to start. You have so many soldiers against the enemy. Let's do this so you guys can see more output. Okay, that's it. No, see more code actually, not more output. Um, all right, so we have some information here, printing some information. Okay, so turn number equals 0, plus plus turn number. Okay, so in other words, starting turn number 1. Okay, and right here we have some other variables. Player val attack, player val defense. Okay, let's talk a little bit about this. Okay, so the you roll a dice for an attack against the enemy, and the player val attack. Remember that the value of the attack and of the defense is a range, right? It has a minimum and it has a maximum value. Okay, so it's like you're rolling a dice, and let's say that your minimum attack is 20 and your maximum attack is 25. So you could get 22, for example, as an attack. So it's going to be stored here in this variable, player val attack. Same for player val defense. Okay, press any number to continue. And then the enemy rolls the dice to defend. So same thing for the enemy. Enemy val defense. Okay, so here's the value of the enemy's defense. Same thing, get a random value from a range. So minimum 15, maximum 22, you can get 18, okay, for example. All right, press any number to continue. So the damage against the enemy, okay, is going to be resulting damage. Resulting damage, the function that we saw just a few minutes ago. The player val attack, the enemy val defense. Okay, so times 50. Okay, so let's say that you attacked with 20, and the enemy defended with 15. Okay, so 5 times 50, that's going to be 250. So the enemy, in other words, loses 250 soldiers. Okay, so if they started the battle with 2,000 soldiers, now they're going to have 1,750 soldiers. Okay, and the damage against the enemy's commander is also equal to resulting damage. Okay, so player val attack, enemy val defense. Okay, so the resulting damage against the worthless enemy is this one here. Okay, so the numbers, okay, minus equals, like I said, so the resulting damage was 250. You lost 250 soldiers. Well, the enemy has, okay? And the commander's points, so they're also gonna lose, this value here. And in case it wasn't clear, okay, just to make it absolutely clear, okay, damage against the enemy, which is, in practice, the net damage against the enemy soldiers, is the resulting damage times 50, okay? And the damage against the enemy commander, okay, it's just, times 1, okay? So if the commander starts the battle with 200 commander's points, okay, and the resulting damage was 9, so 200 minus 9, it's going to be equal to 191, okay? So that's it, basically. Okay, and the strength of the enemy's army. Okay, so their new strength. Okay, is gonna be their current numbers. Okay, see we're using pointers here. Okay, so this is the pointer syntax specifically for structs times their experience. So their experience actually doesn't change. Okay, it remains constant. Their experience divided by 2. Okay, plus their current enemies, their current commanders' points. Okay, that's it. And that is if damage against the enemy has been greater than 0. okay? Because the enemy's armor can block the attack, right? As you guys can see here. So else, the soldier's armor have fully blocked the attack. The resulting damage is, you know, 0. Okay, 0. Okay. And another thing is that, if for some reason their numbers become less than or equal to 0, we're gonna set it to uh, 0. Okay. And a bunch of printfs here. With this attack, the enemy lost so many soldiers. The enemy has X soldiers left. Okay, so just printing out information here. Okay, and then we're gonna check if the battle is over, right? So battle is over. The variable battle is over, which we can see here. Okay, so battle is over is going to be equal to check battle over, the function check battle over, which we saw in the beginning a few minutes ago, right? And if battle is over dot battle over, okay, so in other words, if the battle over is true, then I'm going to return battle is over, okay? Else, we're going to continue with the battle. And return battle is over. So, that means, if it's a function in C, then, we're going to jump out of this, of this battle, okay, of this function, okay? So press any number to continue. So basically, that was your attack, okay? So that was you attacking, okay? That was you attacking. That was the player attacking. Now, the enemy is going to be doing exactly the same thing. Okay? And again, if battle over is true, okay, so you're going to return battle is over, and the we're going to jump out of the function. And we need to, well, from what I saw, at least, we need to do this once when the when you were attacking, when the player is attacking, and we know that we need to do it another time when the enemy is attacking. Okay. All right. Okay. So now let's go run this program. Okay. So as I said in the previous video, I like to use code block for building, for compiling our programs. Okay. Right here, I'm making our program aware of the function that we're going to be using, some variables of type struct, providing values for these variables. Okay, so as I said, we're not going to be integrating the battle function with the creates player army function just yet. Okay. Variables for the enemy and variables for the player. Okay. So first, we're just going to print the information so we can compare it with the end. Okay. Notice that the only thing that is being returned here is the battle over main program. Okay, we're not returning we don't need actually to return the player's army or anything like that, because as I said, we're using pointers, so we're acting directly in memory, which, as far as I know, increases the performance of our program. So that's it. So, what do you guys think? Do pointers increase the performance of our programs? I think they do. But like I said, I am a beginner in programming, so don't trust me that much. All right, so we're gonna build this. Okay, view logs, see if we've got 0 warnings, 0 errors. Okay, so let's run this. Okay. Okay, nice. So I've hard coded some values here. As you can see, you start with 2,500 soldiers and the enemy with 2,700. Okay, so the enemy has more strength than you, but will they be able to beat you? So press any integer to start the combat. Okay, so press an integer number to roll the dice for an attack against the enemy. All right, so let's say attack is 22, their defense is 10, so the resulting damage is gonna be, whoops, gonna be the okay, so 12, right? 12 times 50, as I remember, 600. So they lost 600 soldiers. Okay, well their strength has been diminished, and they lost commander's points as well, and they've lost 2,100 soldiers. So now they're gonna attack you. So the enemy attacks you with 21 attack points. Roll a dice to defend yourself. You defend with 17. So how? So you're gonna lose 200 soldiers, aren't you? So yes, you have lost 200 soldiers. Okay, so the strength of your army. So now starting turn number 2. Okay, roll a dice. 26, 11. Okay, 750 soldiers less. Okay, they attack you with 22 points. You defend with 15, so 7 times 50, 7 times 50, 350 soldiers, so turn number 3. Okay. Okay, let's see, victory. The enemy runs like the worthless rabid dog it is. Okay, because their strength is now 2,036, right? For the battle to be over, okay. So since you are weaker, right? So this here is 2,075, right? 2,075, and their strength reached 2,036, which is less than 2,075, which is the minimum strength. So battle over. True. Battle won. Also true. Victory. The enemy runs like the worthless rabid dog it is. And now you've got, the output for your army here and the player's army. Oh, sorry, the enemy army. Okay, you guys can compare this with the output here on top. So yeah. Okay, folks. So yeah, this was the battle function. I am still deciding what I'm gonna do for the next video. I will make another video about regarding the aftermath of battle function. Okay, because right after you win or you lose the battle, some other things happen, right? So what things happen? I don't know. But you guys can take a look at the source code. I've already uploaded the battle function, the aftermath battle function, and other functions and other stuff in my to my GitHub profile. Repository is gonna be right here in the description. Okay. And but yeah, I'm gonna of course make a video about the what happens after the battle. I still need to write more code. I need to write the main campaign function, and some other functions, some other stuff that I gotta deal with that I've got planned. But I also want to talk about other stuff in terms of programming. Okay, so that's it. Cheers and have a great day.